You know that feeling when you're swimming in the ocean, right? Like maybe you ventured just a little too far from the beach.
Oh, yeah, totally.
And suddenly you realize you can't touch the bottom anymore. You tread water, you look down past your feet, and instead of, reassuring sand, there is just this gradient of blue.
Right, and it just fades into an absolute impenetrable black.
Yes. And your mind instantly starts racing. You're thinking, what is down there? Like, what could be looking up at me right now?
It's a visceral reaction. It really is.
It's an almost universal human fear. And it is exactly that fear mixed with a pretty heavy dose of morbid fascination, I'd say, that we are exploring today.
Definitely.
Welcome to a custom-tailored deep dive into your sources, made specifically for you. I'm your host, here with our resident expert, and today we are going to bridge the vast gap between internet clickbait and the mind-bending biological reality of our oceans.
And I just have to say, it is a phenomenal gap to try and bridge.
Oh, for sure.
The deep ocean is, well, it's one of the few places left on Earth that still feels genuinely alien to us. The sheer volume of unknown space down there, an environment that is actively hostile to our biology, makes it the perfect blank canvas for human imagination.
Right.
And as we'll see as we dig into your provided material, it's a canvas for human anxiety too.
Yeah, that's exactly it. So, to anchor this exploration, we are looking at a really specific cultural artifact from your sources. It's a viral video uploaded back in September 2021 to the platform Bilibili. The title alone basically tells you everything you need to know about how we package the ocean for mass consumption. It translates to, quote, 5 sea monsters captured by cameras lurking on the seabed.
Of course it does.
Right. And just to set the mood, the creator tagged this compilation with keywords like mystery, horror, aliens, prehistoric creatures, and naturally, monsters.
Yeah, we are essentially framing the natural world as a horror movie at that point.
Basically, yeah.
It is the ultimate digital campfire story. But the mission for our deep dive today isn't to just, passively consume a ghost story.
No, yeah.
We want to look past that sensationalized sea monster framing.
Yeah.
We're going to examine the very real, highly skeptical human reactions to these types of viral videos.
Exactly.
And most importantly, we are going to uncover the massive, unprecedented global scientific effort underway right now to actually catalog these bizarre creatures that share the planet with us.
So before we get into the actual science of what is lurking in the dark, we have to talk about how you and I actually consume this information on our screens.
Right, the psychology of it.
Because there is a constant tension between absolute awe and, deep internet skepticism. Whenever a quote-unquote monster pops up on our feeds, we see the grainy footage, we hear the eerie synthesized music the creator layered over it.
Oh, it always has that creepy music.
Always. And a giant shadow moves across the screen.
And the modern reflex kicks in immediately. Yeah. We see something incredible. And our first thought is no longer pure wonder. I mean, our first thought is usually, how is this fake?
Exactly.
If you look at the comment section for this specific Bilibili video, it serves as a perfect microcosm of that modern tension. The internet loves to slap the label of monster onto the unknown to generate clicks, but the audience watching is actually highly analytical.
Okay, let's unpack this, because there is one comment in particular that perfectly captures this modern skepticism.
Oh, the one about the camera angles.
Yes. A user pointed out that in so many of these deep-sea encounters, the photographer seems perfectly positioned. It's as if they already knew some strange creature was going to appear in the very next second.
Like they had a script.
Right. And the camera is just conveniently waiting there to record the weirdness. To put it in perspective, it's like when you're scrolling on social media and you see a video of someone's phone already recording a perfectly framed, supposedly spontaneous prank on the street.
Oh, I hate those. The lighting is good, the framing is flawless.
Yeah, and when it feels a bit too perfect, it immediately makes us question if we're looking at reality or if we're watching a stage show. Like, why were they recording empty water right before the Leviathan swam by?
And that skepticism acts as a survival mechanism in the digital age. The viewer is looking past the subject and questioning the framing of the narrative itself.
Totally.
This raises an important question. Why are we so quick to use terms like alien or monster or just assume outright deception when we encounter deep sea life?
That's a good point. Why is that our default?
It largely comes down to a profound lack of visual vocabulary.
What do you mean by that?
Well, when we see a dog, a bird, or even a spider, we have a mental file folder for it. We understand its geometry. But when a camera illuminates a gelatinous, pulsing, glowing shape floating in the abyss...
Yeah, there's no folder for that.
Exactly. Our brain searches for a reference point, finds nothing, and just defaults to the monster folder.
But another commenter on this exact same video did something brilliant to counter that. They grounded the entire eerie spectacle in reality simply by identifying the first monster in the compilation. They pointed out that the terrifying, red, glowing creature pulsing on screen was, in fact, a vampire squid.
Right, and just by giving it a biological name, they punctured the horror movie tension.
That browns it.
But even the name vampire squid, or its scientific name, Vampiroteuthis infernalis, which literally translates to vampire squid from hell.
Wait, really? From hell?
Yes, it just shows how our surface level bias works. We still project our fears onto it.
I'm really glad you brought up the biology, because calling it a vampire squid from hell makes it sound like it's out there, I don't know, sucking the blood of other fish. What is it actually doing down there that makes it look so monstrous on camera?
It looks monstrous because of its defense mechanisms. Unlike shallow water squid, the vampire squid doesn't shoot a cloud of black ink to escape predators.
Oh, because it's already dark.
Exactly. Ink is completely useless in the pitch black of the deep ocean. Instead, it ejects a cloud of sticky, bioluminescent mucus that grows in the dark.
Ew. Okay, yeah, that looks terrifying on a camera feed.
Right. Furthermore, its arms are connected by a webbing of skin that looks kind of like a black cloak. When it feels threatened, it pulls this cloak up over its own head, a move scientists actually call the pineapple posture.
The pineapple posture. That's kind of cute.
It sounds cute until you realize it exposes rows of fleshy, spike-like projections called cirri. So to a camera lens, it looks like an inside-out, glowing, spiked umbrella.
Yeah, that sounds objectively terrifying. But what is it actually eating if it's not a vampire?
That is the best part. Despite the spiked cloak and the glowing mucus, it is a detritivore.
Okay, meaning?
He uses two long, sticky filaments to capture marine snow, which is essentially just dead skin, fecal matter, and organic debris drifting down from the surface.
Oh, wow.
Yeah, it's basically a deep-sea garbage collector.
That is amazing. It goes from being an otherworldly demon to a harmless scavenger just trying to catch drifting debris.
Yep.
Naming it and understanding its mechanics tethers it to Earth. It proves that what we are looking at in these viral videos aren't mythical leviathans. They are just uncatalogued or rarely seen life forms.
Exactly.
And that realization naturally leads us from the realm of internet speculation into the real world. Because behind the scenes of these viral clips, there is a monumental initiative happening to find the rest of them.
Right, and it's buried right there in the video's description. It's the revelation of an unprecedented cooperative project.
Yeah.
Scientists all over the world are teaming up for an ultimate deep-sea inventory. They're attempting to identify and compile a comprehensive catalog of all marine life.
The numbers involved in this survey report just give you a sense of how vast this unknown frontier really is. According to the data highlighted in your sources, scientists have currently registered 15,304 species of marine fish.
Which sounds like a lot.
It does, but the final estimated number of marine fish species is around 20,000. And if you zoom out even further from just fish to look at the bigger picture, all known marine organisms, including our vampire squid, crustaceans, corals, the total currently sits at 210,000 species.
It is a staggering statistical undertaking.
I look at those numbers and I just have to push back on the logistics here. Like, how is this even physically possible?
It's difficult, to say the least.
And more than that, why are we doing it? The ocean covers over 70% of the Earth's surface and goes down miles into the crust. This sounds like trying to inventory the contents of a massive pitch-black warehouse using only a single tiny laser pointer.
That's a great analogy.
Right. You're standing in the dark, waving this little beam of light around, and every time the light happens to hit something new, you have to scramble to write it down before it swims away. It seems like an impossible task, and honestly, a massive drain on scientific funding when we don't even know what we're looking for.
Well, the laser pointer in a warehouse analogy is remarkably accurate if we were only using cameras.
Oh.
And to address the funding aspect real quick, we cannot protect an ecosystem or understand how global climate shifts are affecting the foundational layers of our planet's food chain if we don't even know what lives there.
Fair point.
We need baseline data. Furthermore, the bizarre adaptations of these deep-sea creatures hold immense potential for biomedical research. But your logistical question is the most crucial one. How do you count them?
Right.
Scientists aren't just relying on cameras anymore. They use ROVs, remotely operated vehicles. equipped with suction tubes and delicate robotic arms to take physical samples. But the real game changer is eDNA.
eDNA!
Yeah, environmental DNA.
Wait, like dusting for genetic fingerprints at a crime scene?
Exactly like that. As marine animals swim through the water, they naturally shed skin cells, mucus, waste.
Just leaving a trail.
Right. So scientists can send a probe down into that pitch-black warehouse, scoop up a few liters of water, sequence the genetic material floating in it, and identify the presence of species without ever actually seeing them on camera.
Oh, wow.
They're literally vacuuming up the genetic evidence of the deep.
That completely changes the methodology, but it still leaves a major question about the math for me. If we are just scooping up water and finding random DNA, how do statisticians arrive at that 20,000 estimate for fish?
Right. The ceiling.
Yeah, if it's an endless dark void, how do they know where the ceiling is? Why not 50,000 species?
What's fascinating here is they use a mathematical model called a species accumulation curve.
Okay, how does that work?
Imagine you cast a net into a newly discovered deep-sea trench. The first time you pull it up, maybe find 10 brand new species.
Okay.
You cast it again, and you find 8 new ones and 2 you already caught the first time. As you keep casting the net, or taking eDNA samples in this case, the rate of discovering new species begins to slow down.
Oh, I see.
Eventually, you pull up a sample and find 0 new species. You've only caught things you've already documented.
So the curve flattens out.
Precisely. By tracking the rate at which that curve flattens relative to the effort expended, statisticians can project the asymptote, the theoretical ceiling.
That makes so much sense.
Yeah, that is how they arrive at the estimate that there are roughly 4,700 fish species left to find to hit that 20,000 mark. That gap isn't just a random guess. It's a mathematically calculated frontier of discovery.
Okay, but if we're sequencing the DNA of things we haven't even visually documented yet, it begs the question, what happens when we actually get a camera in front of them at those depths?
Things get weird.
Really weird, because the environment down there is forcing adaptations that look like they basically violate the laws of physics. Let's look at the environmental context provided by the surrounding videos on this Bilibili platform.
The tags again.
Yeah, you see related content talking about megalophobia, which is the fear of giant objects, and deep-sea-phobia tests. The source material mentions these videos are basically endurance tests for human anxiety. People are actively seeking out this feeling of dread.
Because the environment itself triggers something deeply primal in us.
Yeah.
When we talk about the deep sea, particularly the trenches where some of these undocumented species live, we are talking about depths of up to 10,000 meters.
That's just incomprehensible.
The Mariana Trench goes down nearly 11,000 meters.
Yeah.
To put that in perspective, if you dropped Mount Everest into the Mariana Trench,
Yeah.
its peak would still be over a mile underwater.
That is insane. At 10,000 meters down, the pressure is immense. It's roughly 8 tons per square inch. That is like having the weight of an elephant balanced on a postage stamp on every inch of your body.
Exactly.
The ocean is pitch black, and the temperature is hovering just above freezing.
And at those depths, the rules of biology, as we understand them on the surface, are completely rewritten. Survival requires physiological adaptations that seem, to our surface-dwelling eyes, completely absurd. Food is incredibly scarce, and finding a mate is even harder.
Here's where it gets really interesting, because the sources highlight a specific biological fact that illustrates this perfectly. Among these deep-sea encounters, there is a description of a creature with one of the most extreme reproductive strategies on the planet. I am talking about the deep-sea anglerfish.
Oh, yes.
Specifically the dynamic between the male and the female.
The anglerfish is basically the poster child for deep-sea monstrosity, usually known for the glowing lure hanging over the female's head to attract prey.
Right, everyone knows the light bulb on the head.
But it's the male's life cycle that just defies belief.
Because the male anglerfish's entire existence, his whole purpose in life, is dedicated to finding a female in the pitch black. He is tiny, a fraction of her size, and he has highly developed olfactory organs just to sniff her out in the dark void.
Just swimming around smelling for a mate.
And when he finally finds her, he doesn't just mate with her and swim away, he bites her, and then he literally fuses his body to hers.
It is a process called sexual parasitism?
Parasitism is putting it mildly. When he bites her, he releases an enzyme that dissolves the skin of his mouth and her body, fusing them together down to the blood vessel level.
Yeah, they literally share a circulatory system at that point.
Once connected, the male begins to atrophy. He loses his eyes, his internal organs, his fins. He dissolves until he becomes nothing more than a living, sperm-producing appendage permanently attached to her body.
It's wild.
He stays like that until they both die. We are out here looking for shape-shifting aliens in outer space, making movies about extraterrestrial body horror, and meanwhile, we have males dissolving their own organs to become attached biological components right here in our own oceans.
I know it sounds horrific when you describe the mechanism: enzymes melting flesh, eyes withering away, circulatory systems merging.
It is horrific.
But if we connect this to the bigger picture, we have to look at the why behind this extreme biological mechanism. Think about the logistics of that 10,000-meter deep, pitch-black warehouse we discussed earlier.
Right. It's not just dark, it's mostly empty space.
Exactly. In the pelagic void of the deep ocean, the population density of any given species is incredibly low. The sheer statistical probability of a male and a female anglerfish of the exact same species bumping into each other in millions of cubic miles of absolute dark is almost zero.
Oh, I see.
It might happen once in a lifetime if the male is incredibly lucky.
So if he simply mated with her and let go to swim back into the dark, he would likely never find another female ever again. And she might never find another male when she is actually ready to release her eggs.
The species would go extinct. Therefore, evolution created a permanent, albeit gruesome-sounding solution.
Yeah.
By physically fusing his circulatory system with hers, he ensures that whenever she is ready to reproduce, which might be years down the line, he is already there.
Wow.
He's drawing nutrients from her bloodstream and providing exactly what she needs in return. What internet clickbait frames as horror or a monster is actually just nature's brutal, beautiful efficiency in the extreme dark.
Brutal efficiency is the perfect way to phrase it. The clickbait video sees a terrifying monster with weird lumps on its side, but evolutionary biology sees a masterpiece of problem solving. It's all about how you frame the data.
And that framing is exactly what this massive scientific cataloging effort is slowly trying to shift.
Right.
By registering those 15,304 fish, filtering the water for eDNA, and plotting species accumulation curves to find the remaining 5,000, scientists are replacing our fear of the unknown with the rigorous understanding of the known. Every time an ROV shines a light on a new species, it shrinks the shadows just a little bit more.
Which really brings this entire deep dive full circle for us.
Yeah.
We started today looking at the internet's obsession with a viral compilation of sea monsters, complete with the creepy Bilibili tags and the natural human skepticism of perfectly framed videos.
Mm-hmm.
We unpacked why a creature like the vampire squid looks like a demon but acts like a deep-sea garbage collector.
We moved from the mythology of the digital campfire to the hard mechanics of a live biological census.
And we learned that reality, like a male anglerfish navigating the crushing, freezing pressure of 10,000 meters only to permanently dissolve his own face and organs into his mate, is infinitely stranger and honestly much more fascinating than any poorly lit ghost story you could find online. So the next time you are scrolling late at night and you see a viral video of a strange gelatinous creature floating in the abyss, I want you to remember this conversation. Remember that you aren't looking at a monster. You are looking at a single data point in a massive, ongoing scientific census of our planet.
It is a humbling reminder that we do not fully understand our own home yet. There are still vast frontiers left to illuminate and countless adaptations we haven't even begun to imagine.
So what does this all mean? We've talked about the science, the statistical modeling, and the bizarre biology of the deep. But I want to leave you with a new angle to ponder, something that ties right back into the psychology of how we view the ocean. In the sources we explored, nestled right next to the videos of deep-sea creatures, were videos about ghost ships and tests for deep-sea phobia.
Because the environment itself is inextricably linked to our concept of terror. The ocean represents the ultimate loss of control.
Exactly. If our own planet's biology and environments can instantly trigger such deep-seated psychological phobias in us, inspiring myths of ghosts, aliens, and sea monsters simply because life adapted to survive in the dark and the cold, what does that say about human psychology?
That's a profound question.
Are we as a species biologically wired to be terrified of the very ocean that gave rise to all life on Earth? The next time you find yourself treading water, looking down into that fading gradient of blue, ask yourself, are you afraid of what's actually down there, or are you just fundamentally afraid of the dark?